Hey everyone, Mike here. I at Chapter 8, Systems of Equations. We're going to start with Section 8.1, and we're going to define some systems, look at what makes a solution, some vocabulary with systems, consistent or inconsistent, dependent or independent. Begin with the system of equations is a collection of equations involving variables. Formally, we use a brace to indicate that all of these equations are part of a system, but not everyone does that. Notably, this textbook does not. So a system can be made up of any number of equations and variables. We're going to start with looking at two like this, but we will, in our later sections, look at systems of three equations and three unknowns. But notice how I said three equations and three unknowns. We want the same number of equations and variables. That's when we are most likely to find solution. So what makes up a solution? Well, for this system, the point -2, -3 is a solution, since when we substitute, we'll have -3 is equal to -2 minus 1, which is true, and -3 is equal to 2 times -2 plus 1. -4 plus 1, also true. They're both true statements. We could also write it like this, as x is equal to one number, y is equal to another, or like this as an ordered pair. So what about the values 3, 2, and this system right here? 2x plus 3y is equal to x minus 3y is equal to -5. Are these solutions? Well, we're going to start by substituting into the first equation. We'll have 2 times 3 plus 3 times 2. That's 6 plus 6, which is true. It is 12. But when we substitute into the second equation, we get 3 minus 3 times 2, which is 3 minus 6. That's -3, and -3 is not -5 like we needed. That means that this is not a solution. It doesn't satisfy both equations in the system. We need both equations to be true. What about 4, 2? Is that a solution to this system? Well, let's see. 4 times 4 minus 3 times 2. 10. 4 plus 2 times 4. 4 plus 8. Nope, not 2 times 4. I'm sorry. 2 times 2 is equal to 4. Oops, got ahead of myself. 4 plus 2 times 2, 4 plus 4, which is 8. This is true. So is it a solution? Yes, it is. Again, we substitute. We see if we get equal, if the statements are true. And in this case, it is a solution. And we can also solve these equations by graphing them. I can take the line y is equal to 3x right here, graph it, and I get this red line. Oops. Then I can go ahead and I can graph y is equal to x plus 4. That gets us this blue line. And we see where they intersect, and that's right here, which is 2, 6. So 2, 6 represents our solution, and we always want to be sure to check it, that 6 is equal to 3 times 2, and that 6 is equal to 2 plus 4. Both of these are true, so this is indeed our solution, and we've solved it by graphing. So if I wanted to solve this equation by graphing, I could just take two values whose difference is 2, like 4 minus 2 is 2, and 2 minus 0 is 2, and I'd go to 4, 2. and I'd go to 2, 0. I could go ahead and connect those. And then I could take pairs of numbers that add to 6, like, oh, I don't know, 4, 2, and 6, 0. 4, 2, and then 6, 0 is down there. And connect those dots. 6, 0, 4, 2. And we can see that right there, that's our solution. 4, 2. It's a point that both lines have in common. Or we could go ahead and get it into slope-intercept form, graph it that way, and we get that the solution is 4, 2. Again, we can get them into slope-intercept form, graph our solutions, and where they intersect. In this case, -6, -2 is the solution to the system. It's an ordered pair. What about this case? We have y is equal to 2x, 3y minus 6 is equal to 6. Let's get them into slope-intercept form, and then let's graph them. Uh-oh. Right here we have y is equal to 2x, yeah? Here's y is equal to 2x, the red line. Then our blue line is y is equal to 2x plus 2. Got that intercept of plus 2 up there. So these two lines are parallel, and they're not going to have a solution. When lines are parallel like this, we call the system inconsistent. Systems that are inconsistent have no solutions. Systems that have a solution are called consistent. So it's either consistent with a solution or inconsistent without a solution. Looking. What about this? 4y is equal to 2x minus 8, and y plus 2 is equal to 1/2 x. Once again, let's get these into slope-intercept form. And when we do that, it's the same line, right? 4y is equal to 2x minus 8. We divide everything by 4. 2/4 x minus 8/4. Y is 1/2 x minus 2. And when we have the other line there, y plus 2 is equal to 1/2 x. Y is equal to 1/2 x minus 2. It's the same line. So here's our first line. Here's our second line. There they are both together. Any point on this line is a solution to both of them. There's an infinite number of solutions. Since we have like only one unique line, we only have one unique equation, this gets its own special vocab word. This gets called dependent. When we only have one equation, we have a dependent system. Our other systems had two lines, two different equations. They were independent. System A right here, we have two lines, but they're parallel. So this is independent. There we go. Independent. But there's no solution, so they're inconsistent. Over here with line B, we only have one line, so it's dependent. but there is a solution, any point on that line, so it's consistent. System C has 2 lines, so it's independent. And there's one nice solution, so it's consistent. And system D is like A, independent, inconsistent. Right. We can solve by graphing, and something like this, where they cross once, is going to be consistent and independent. And that solution would be 8-2. All right. That's it for this section. I'll see you next time where we talk about substitution.